So today, we said we are looking at what we call partial differentials. Partial differentials. And partial differentials, you can write this. Partial differentials, you write that these are results obtained. These are results obtained when a multivariate function is differentiated with respect to each independent variable at a time. Each independent variable at a time. Because the other independent variable or variables, the other independent variable or variables treated as constants. Are treated as constants. Treated as constants. So we can have it as relation 1. As relation 1. We are given a function y is equals to x cubed plus 4xy, plus 4xz plus z squared plus 8. We are given a function like that. So partial differentials So you differentiate y with respect to x first. Was the first independent variable. So in that case, this x here gives us 3x what? Squared. Then this x here is raised to power 1. So it's going to give us 1 times 4 z. Yeah, so it's going to be 4z. Now this one does not have does not have x, so it becomes 0. Even this one does not have x, it becomes 0. Then dy dz, the differential of y with respect to z. Differential y with respect to z. Now this one does not have what? Z. So it becomes 0. This one has z, which is raised to power 1. So it is going to be 1 times 4x. So it's going to be 4x. This one here has z. So it's going to be what? 2z. And this one does not have z, so it becomes what? 0. Okay. Example 2. Example 2. You are given a function y is equals to 16x raised to power 4 plus x raised to power 6 z raised to power 4 minus 12z squared plus 14. So the partial differentials dy dx is this one, so you multiply by 4, you get 64, right? 64x cubed, because there is an x. Then here you get plus 6x raised to power 5, z raised to power 4. So z remains a constant. Minus this becomes 0, plus this becomes 0, because those two do not have x. dy dz, this one becomes 0, because there is no z. This one becomes 4x raised to power 6. 4x raised to power 6 z cubed minus 24z plus 0. So that is how you solve partial differentials. Let's proceed now and you write presence of a budget constraint. 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 And write that a budget constraint is a scarce resource. Such as money, capacity, etc. In such cases, the following function is created. The following function is created. L is equals to f of xy plus lambda of g of xy. Lambda g of xy. Where L is called Lagrange function. Lagrange function. F of xy, the function was variable. And it's being maximized or minimized. So f of xy is the function of variable. Its value is being maximized or minimized. G of xy is the function for the budget constraint. For the budget constraints. Of budget constraints. This is changing f of xy when g of xy changes by 1 unit. Yeah, that's what we call a grade function. So illustration 1. Illustration 1. So, example 1, you write that the revenue function in a company is R is equals to Q squared plus 3QA plus A squared. A squared. Stop. The budget constraints. Is given by Q plus A is equals to 100. is equals to 100. Determine the maximum revenue. Determine the maximum revenue. So in the solution, we are going to say that L is f of xy plus lambda g of xy. Timothy, good morning and welcome. So in that case, our f of xy is the function that we are maximizing, this one. So it's going to be q squared plus 3qa plus a squared plus lambda g of xy. Now g of xy is this one, q plus a. Now here, when you are writing it, you now bring this other one to the other side, you say minus 100. Q plus a minus 100. So you now open the brackets and tell us L is q squared plus 3qa plus a squared plus lambda q plus lambda a minus 100 lambda. So that becomes the function. So the partial differentials, you say the differential Lagrange with respect to q. With respect to q. So this one becomes 2q. This one becomes 3a. This one has no q, so it becomes 0. This one has q, so we are left with lambda. These two have no q's, they become zeros. Now you tell us this is equal to 0 and you call it equation number 1. That is equal to 0 and you call it equation number 1. Then you differentiate the Lagrange with respect to a. Differentiate Lagrange with respect to a. So this one has no a, so it becomes 0. This one has an a, so we are left with 3q. This one becomes 2a. This one has no a, this one has a, so plus lambda equals 0. Then you differentiate Lagrange with respect to lambda. Differentiate Lagrange with respect to lambda. And this one, all these do not have lambda. So we start here, this becomes q. This becomes a. This becomes minus 100. Should be equal to 0. And you call that equation number 3. Number 3. Then you say removing lambda from 1 and 2. Removing lambda from 1 and 2. we're going to say 2q plus 3a plus lambda is 0. 3q plus 2a plus lambda is 0. You say minus. So this is left as minus q plus a is equals to 0. This one you call it equation number 4. Equation number 4. Then you say removing q from 3 and 4. Moving q from 3 and 4. So this one of 3 becomes q plus a is equals to 100. And minus q plus a is equals to 0. So what you need to do is to add. What you need to do is to add so that q goes. We are left with 2a being equal to 100, and therefore a must be equal to 50. So using equation 4, we are going to say minus q plus 50 is 0. And therefore, it goes without saying that q is what? 50 as well. So we have what we required for us to be able to maximize the profits. What we require to maximize profits. So we are going to say what? Hence, maximum revenue, that is R, will be equal to Q squared. Q squared is 50 squared plus 3Q8. 3 times 50 times 50 plus 50 squared. You have the answer? Yeah, so those are the issues of differentiation that we needed to understand. Let's now proceed and look at integration. Integration, and write that to integrate means to combine. To integrate means to combine. Sum or total. There are 3 ways of getting a total. There are 3 ways of getting a total. One is addition. Number 2 is multiplication. And number 3 is integration. The 3 methods do not always give the same answer. The 3 methods do not always give the same answer. The appropriate method to use, depends on what has been provided. The appropriate method to use depends on what has been provided. Depends on what has been provided. Integration is used where marginals have been provided. Marginals have been provided. When a function is integrated, it goes back to the original status. Function is integrated, it goes back to the original status. That is integral of dy dx with respect to x should give you y plus c. Integrate dy dx with respect to x should give you y plus c, where c is called constant of integration. Another point down there, we write that the constant of integration represents a constant that became 0 during differentiation. Constant that became 0 during differentiation. For a total revenue function, C is equal to 0. C is equal to 0. Another point is for a total cost function, C is equal to the fixed costs. It's equal to the fixed costs. Okay. There are two types, rather, first of all, you note that integration is the reverse process of differentiation. Integration is the reverse process of differentiation. divided into two areas. Divided into two areas. One is called indefinite integration. The second one is called definite. Divided into two areas. First one is called indefinite. The second one is called definite integration. Let's start with the first one, indefinite integration. Indefinite integration. Definite integration. And write that this is where there are no limits. This is where there are no limits. No limits within which a function is integrated. In which a function is integrated. So example one. We are going to integrate x cubed with respect to x. Hii kasema ukiandika hivi it means integrate. So the solution tunasema when you integrate you get back the original y. So y is equals to, so you take this one x raised power 3 that way. You do the reverse of differentiation. Differentiation, we were doing two things yesterday. We are starting by multiplying, and then we would subtract. So to reverse that, you add, then you divide. So we add back 1. Yeah? You divide by the new power so that we cancel the multiplication that we did. Then tumesema you add c to represent any constant that became c. So the final answer will be y is equals to x raised power 4 out of 4 plus c. Now, if you know the value of y, the value of x, you can substitute them in that function to know the value of what? C. But come we do it like now in this case, you just leave it that. However, tumesema, if you're dealing with a revenue function, this one will always be 0. And if you're dealing with the cost function, this one will always be the fixed cost. So example 2. We are told to integrate 10x raised power 4 minus 5x raised power minus 4 3x squared plus 10. We are told to integrate a function like that. So the solution is that y is equals to 10x raised power 4. So you first of all add back 1, divide by the new power 4 plus minus 5x raised power minus 4. You add back 1. You divide by minus 4 plus 1. Plus 3x squared, you add back 1, divide by the new power. Divide by the new power, 2 plus 1. Plus 10, which is currently x raised power 0. You add back 1, you divide by 0 plus 1. Then you obviously bring the constant of integration c. Constant of integration c. So this ends up as y. This will be 2x raised power 5. This becomes plus 5x raised power minus 3. And divide by 3. Yeah. This negative cancels this, become positive. Plus, this 3 cancels this, you are left with x raised power 3 plus 10x plus 3. So that is what we call indefinite integration. Let's now look at definite integration, number 2. Definite integration. Definite integration. And we write that this is where there are limits within which integration is done. There are limits within which integration is done. It's stated as integral between a and b of f of x respect to x is given as f of b minus f of a, where e is the lower limit b is the upper limit. Maybe here I would say equals area, as ongeza hivyo. This one equals area. Now area can be used to present anything. Could be total revenue, could be total cost, total profits, anything that you are computing. Yeah, I could give you a graphic representation so that you are able to visualize something like this. This is the f of x. Just something small. This is A, this is B, this is x axis, this is y axis. This is where we have area. So we are looking for that area. That's something small. That. So example 1. Example 1. Integrate between 0 and 3. X squared plus 2 with respect to x. So solution is area is equal to, so you take this one, the way it is, x squared, you add back 1, you divide by the new power, plus 2 currently x raised power 0. You add back 1, divide by the new power. But now this one, we do not add the constant of integration because it cancels out. So what we do is that to natural slope like that. And that slope is read in the range of 0 to 3. So the limits in the range of 0 to 3. So you proceed here and say this is x cubed out of 3 plus 2x in the range of 0 to 3. The range of 0 to 3. Sasa, you just come here and do what? Substitute. So, substituting, we start with the higher one. So you say 3 cubed out of 3 plus 2 times 3. Then you say minus 0 cubed out of 3 plus 2 times 0. So you solve that. What is the answer? 9. You sure? 9, eh? Okay. So the answer is 9. Three cubed is what?
15.
27. Divide by 3. 15. So the answer is not 9. Still, it's 15, yes. The answer is 15. Okay, example 2. We are told to integrate between 2 and 4. 5x raised power 4 plus 8x cubed minus 10 with respect to x. Given a function like that, to integrate. Then in the solution, tell us that y is equals to 5x raised power 4, you add back 1, you divide by the new power, 4 plus 1. Plus 8x cubed, you add back 1, divide by the new power, 3 plus 1. Minus 10x raised power 0, you add back 1, divide by the new power, and then you say in the range of what? 2 to 4. The range of 2 to 4. So this becomes y, which is our area. It's going to be these cancels, so we are left with x raised power 5 plus 2x raised power 4 minus 10x in the range of 2 to 4. So y, which I'm saying is still representing our area, will be 4 raised power 5 plus 2 times 4 raised power 4 minus 10 times 4. Then you say minus. You start again. You say 2 raised power 5 plus 2 times 2 raised power 4 minus 10 times 2. So what is the answer? 1452. Okay, good. 1452. So that is all that we needed to say about functions, calculus, differentiation, and integration. So we need now to do some illustration questions. And I want us to go to our past papers. There is this question of June 2013. Question of June 2013. Question 1B. June 2013. Question 1B. Is on around 364. Not wrong. An electronic company manufactures and sells its computers. The marginal cost in thousands is given by the expression MC is equals to X plus 50, where X is the number of computers produced and sold. Fixed cost amount to 500,000. However, the total revenue function is unknown, but the sales manager is convinced that the total revenue can be represented by a quadratic function. The sales manager gathered the following data on sales of the computers. So we are given that you are required to get the total profit function. So in doing that, you start by coming here and saying total profit should be equal to total revenue minus total cost. Total profit should be equal to total revenue minus total cost. Once you have written the formula, you start looking for the components of that formula. The first component is the total cost, or let me start with the total revenue. Total revenue, we have been given data. So what we require to do is to develop the equation, because we are told it is unknown and we have been given data. And this is, I think, equation we developed yesterday. So look at what we did yesterday and give me the answer. What? When we look at quadratic functions, the equation that we developed, equal number of computers and revenues. Negative 2x squared plus 185x. Yes. So that is what you are supposed to do, or what we did. Get the total revenue. From there, let's go for total costs. Now, total cost, what you have been given is marginal costs. And I've said there are three ways of getting a total. You can either integrate, you can add, or you can multiply. And what method to use depends on what has been provided. So here we have been given the marginal cost. So our TC should be the integral of x plus 50 with respect to x. So this is a case of what you have called indefinite integration. It has no limits. So in integrating this, we get x, currently is power 1, you add back 1, divide by the new power, 1 plus 1. Then 50, currently x is power 0. You add back 1, you divide by the new power, 0 plus 1. And then in the indefinite tumesema, you bring the constant of integration c. So in solving this, this is a half, so 0.5 x squared plus 50x plus, now you don't write c, you write the value of c, which I've told you when you're dealing with total cost, the value of c is the fixed cost. So that is here. And therefore, total profit huwa inasimamiwa na pi. We normally use the equation pi. I mean the symbol pi. So you take the revenue as minus 2x squared plus 185x. You come at minus 0.5x squared plus 50x plus 500. So you open the brackets and tell us pi is equal to minus 2x squared plus 185x minus 0.5x squared minus 50x minus 500 minus 500. So you put like terms together so that you end up with pi. Now this square to join this one, so that we're left with minus 2.5x squared. Alafu this one plus this one, you get plus 135x minus 500. So that is what we call the total profit function. Then when they ask you maximum profit, if you're looking for maximum profit, we normally say the differential pi with respect to x should be 0. If you differentiate the function of the profit and you make it 0, that is when you get. That is, if I seek to differentiate with respect to x, this function, minus 2.5x squared plus 135x minus 500, this one should be equal to 0. You differentiate that function. It should give you a 0. Sasa, in differentiating this, we get minus 5x plus 135 should be equal to 0. So from there, tell me x is what? Yeah? 27. Then, thus, profit should be equal to profit should be equal to, sasa hii unaiweka kwa hii function ilikuwa nayo, minus 2.5 times 27 squared plus 135 times 27 minus 500. So we help with that. Okay, let's go to this question of September 2015. September 2015, question 1D. September 2015, 1D. A farm has a linear demand function for its product. When the price of the product is shillings 220, the quantity demanded is 40 units. When the price increases to 240, the quantity demanded becomes 30 units. In addition, the farm's marginal cost is that, fixed cost is that. Therefore, that maximizes profits. I'm on page 52. The question of September 2015. Question 1B. With bracket. So in solving this one, what you need first is to get the price function. The price, some people call it demand function. Price or demand function. That's what we call it in economics. And I told you the format is P is equals to A minus BQ. And remember, Q is used interchangeably with X. So unaweza tumia X, unaweza tumia Q. So because it's a linear function, we said the linear function yesterday requires 2 points. So we are told when the price is 220, so when the price is 220 here, Q, the quantity is 40, so 40B. And when the prices goes to 240, we have 30 units. 30 units. So now you simply get the difference here. Say minus, so this gives us minus 20 be equal to minus 10B. Therefore, B should be equal to 2. That's it. Okay. So if that is so, you come here and tell us 220 is equals to A minus 40 times 2. So tell me A is what? $300. So price should be equal to 300 minus 2 Q. The next thing that you need to develop here is called total revenue. Now, total revenue R is price times units sold. If you are looking for the total revenue, it is always the selling price times the number of units sold. So sasa hii itakuwa our price we know is 300 minus 2Q. And the units we know they are Q. So this becomes 300Q minus 2Q squared. The next thing is to get total costs. Now, total costs, what we have been given here in this equation, marginal cost. So TC, we will have to get it by integrating 40Q plus 2Q squared plus 2 with respect to Q. With respect to Q. So this one, TC, becomes 40Q currently is per 1. So you add back 1. Divide by 1 plus 1. Plus 2Q squared, you add back 1. Divide by the new power. Plus 2, currently Q is power 0. You add 1. You divide by the new power. Then you add C, the constant of integration. Add C, the constant of integration. So our total cost here will be what? 20Q squared plus 2Q cubed out of 3 plus 2Q plus C, which is the fixed cost. The fixed cost is what? 5. Sindio? So from there, let's get the total profit. Total profit by, going by the formula we had written earlier, it is the revenue 300Q minus 2Q squared. You minus the total cost, which is 20Q squared plus 2Q cubed out of 3 plus 2Q plus 5. Sasa hiyo, you open the brackets and get 300Q minus 2Q squared minus 2Q squared minus 2Q cubed out of 3 minus 2Q minus 5. So pi becomes this 300 to join this one, so tunaachiwa what? 298, 298Q. Then this square to join this, you have to achieve minus 22Q squared. This one minus 2Q cubed out of 3 minus 5. So that is the profit function. So that is the profit function. Now you proceed and tell us maximum profit. If you are looking for maximum profit. If you are looking for maximum profit, the differential with respect to Q of this one, 298 Q minus 22Q squared minus 2Q cubed out of 3 minus 5 should be equal to what? 0. If you are looking for the maximum profit, it should give you 0 there. So let's differentiate. Hii inatoka as to what? 298 minus 44 Q. Haya, this one, hii 3 inakuja hapo inakuwa cancelled, So tunabakisha minus 2Q squared. 0. So that becomes a quadratic function to do. So you proceed and tell us using quadratic formula. Using quadratic formula, which we know is written as Q is equals to minus B plus or minus B squared minus 4AC. This one at the square root. You divide by 2A. Yeah, sasa hii is going to be B in this one. So minus 44, tunaachiwa 44. Plus 44 squared minus 4 times A is this one that has square, so minus 2. C is this one, 298. Hivyo. Sasa hii ikuwe kwa square root hivyo. Alafu the whole of this ikuwe kwa 2 times A is minus 2. Uchukua calculator, ndio uniambie hii iko kwa square root. Sasa hapa umepata 65.73. So this means we are going to have 44 plus 65.73. You divide by minus 4, or 44 minus 65.73. You divide by minus 4. This one. Negative 5 points. 5.3. And ingine takuwa negative what? 20. $7.4. So because you cannot have a negative, you take the positive, 5.3. Hence, profit. Sasa hii 5.3 ndio utaweka kwa ile profit function tulikuwa nayo, Yeah. So we are going to stop there. I'm rushing to NTV for some interview. But we are basically through with that. I think I'm again going to get another video that has more illustrations on functions. Make sure you go through them. Yeah, they are really helpful. I don't know whether I sent you one for Markov. Okay. Sikuwatumia Markov. Okay, I'll send right away. Yeah. Okay. So, thank you.